terms of the reverser, we got the reverser design, the control of it, and the indication of it. So we can see in this picture with the thrust reversers in the stowed position, there's a nice smooth way for all the bypass air to come through and out the back engine, at the back of the engine like this. Once we deploy the thrust reversers, these sea ducts move aft, but the sea ducts, not only by moving aft, they also operate these doors, okay, these blocker doors. They put them in the closed position, and therefore the air that was previously bypassing down the back end of the engine has nowhere to go but through these cascades. These cascades are installed in a way that they divert the air in a forward motion, and by doing that, they reverse the flow of the air and therefore slow the aircraft down. These are all the components. An important component, this needs to be spoken about, are these sink shafts. Okay, so each sea duct has 3 actuators that move the whole actuator, the sea duct, the half aft or forward, depending if we're deploying or stowing. And these sink shafts keep all 3 actuators synchronized so that this big area here is uniformly moving aft and forward into the deploy and stow position so that it doesn't go skew. Yeah, so these sink shafts are important. So the thrust reverser half moves as a one piece, moved in unison by these 3 actuators. In terms of safety, I don't know if you watched the video the other day of us opening the thrust reverser. It's very important to make the thrust reversers safe when you're going to conduct maintenance. So this is pretty much an old system where you pump the reverser with a hand pump to the full open position. Once it's in the full open position, you put this actuator safety lock onto the piston of the opening actuator with some pins, and that prevents it. Even if the actuating cylinder collapsed, for example, this piece of metal here would not allow it to close, and therefore it makes it safe for people to be underneath it working. We have some safety latches. They're under tension to keep the 2 thrust reverser halves connected and taut, and they are opened and closed in a specific order to relieve the tension before we unlock them. Component locations. Okay, so under here in this auto throttle control unit is the control switches, the arm switches, the stow switches, and the sink lock switches that give control to the thrust reverser. The thrust reverser control valve modules. If you saw the other day when we opened the thrust reverser, we had to deactivate the thrust reverser before we opened it. So we moved this control valve lever and then put the pin in. There is a separate brain for the thrust reversers called the engine accessory unit, the EAU, which enables us to monitor and test the thrust reversers in terms of if they time out or have a minor fault. And the thrust reverser halves, or sea ducts, because they're in the shape of the sea, have the hydraulic actuators, the sink shafts, the sink locks, the translating sleeve, lock and stow sensors. Don't let this frighten you. Okay, this is just a simple diagram on how the thrust reverser electrically operates. And as long as so we start here, as long as the engine fire handle is not pulled, then the thrust reverser can stow or deploy when the thrust reverser is armed. In order to stow, the arm and the stow switch have to be made. In order to deploy, the arm and the deploy switches have to be made. For the arm switch to be made, I have to be on the ground or within 10 feet radio altitude. Once I'm within 10 feet radio altitude or on the ground, then this switch is armed. Once this is armed, it enables the thrust lever to be operated if, for example, we're in the stowed position because that's how they normally are, when we want to now deploy, I will engage the deploy solenoid in the thrust reverser control valve module and direct the hydraulic power to the thrust reverser to push the actuators to deploy, to open the thrust reversers. And that's what will happen. Once we operate the handle, when the system is armed, then they will move if I have hydraulics on. So they've deployed, I finished my job, I put the thrust reversers back into the stow position, and now operate the stow switch. Okay, and the process will be reversed, and the thrust reversers will go back into their stowed position within a given certain period of time. If not, then we'll get a warning that the reverser might time out, and we have to manually do something about it. So we have LVDTs. LVDT is a linear variable differential transformer, which means it's basically a transformer that measures a changing voltage on a sliding scale on a moving actuator, okay, on a linear actuator. And proximity sensors are two-way indicating devices that will show close or far or near or far indications, either when the actuator is or a switching operation is closed or not closed. So they transmit their information back to the EC. We get a reverser light on, either if there is a reverser fault or if the reverser is going into the restow position. We get a reverser in amber when we deploy and the reverser is in transit. And we get a reverser green just above the N1 when the reverser is successfully deployed. There's a better picture of it, how it all works. So the engine control light, we said, might come on if there is a reverser deployed in flight, for example, then that's big problems. We have to land. Or if the reverser is deployed before departure, then we're going to have this engine control light on and we have to do something about it. A reverser light comes on when there is a fault or when the reverser is being stowed, in the process of being stowed. And the indication of the reverser, its condition, is here. There are three options here for each reverser. If the reverser in flight or on the ground is stowed, there is no indication. If then you pull the reverser to deploy it, while it's in transit, it goes amber. If it's deployed successfully in its correct position, it goes green. That's the indication. Okay, those are the three possibles of this indicator here. This is the LVDT, the linear variable differential transformer. Okay, that measures voltage on a sliding scale and shows not only if an actuator is moving or not, but how much as well.